All right, IVSL1. Today we're going to talk a little bit about the quadratic formula. So the quadratic formula is used or should be used when you're trying to solve a quadratic, you're setting it equal to 0, and you can't factor it, like your factoring tricks aren't working, your complete square is way too messy with fractions and radicals. So I think you should think of the quadratic formula as a last resort. Yes, I know the quadratic formula works with any quadratic if you did every single time, but I think it's way too overkill, and it lends itself easily to make mistakes because there's so much computation involved with it. So once again, I only use the quadratic formula when I'm backed into a corner, and it's the last tool that will work to find the x-intercepts, roots, zeros, or just solving for x. So that's what we use it for. Find roots, zeros, x-intercepts, or just when a quadratic is set equal to 0. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Mr. Jolly will walk you guys through the song, the Frere Jacques song. We're going to do a couple examples of the quadratic formula. So here you see that a is equal to 1, b is equal to negative 6, and c is equal to 4. So you sing your song and you say x is equal to negative b plus or minus the square root of b squared minus 4 times, to extend that, a times c. And then this is all over 2a. Now, all the ingredients are plugged in, but we just got to do a lot of cleanup. So negative 6 is a positive 6. We'll let that plus minus hang out for now. Now, inside the square root, b squared minus 4ac, we'll get 36 minus 16. And this is all divisible by 2. Next step, we're going to simplify the 36 minus 16. So we get the square root of 20 all over 2. Now, I really want to start dividing things by 2 because of this big divide by 2 in the bottom. But what we need to do first is simplify this radical. So to simplify that radical, if you think about the square root of 20, you need to find the biggest perfect square that comes out of 20. So perfect squares are square numbers like 1, 4, 9, 16, 25. They're like, 2 squared, 3 squared, 4 squared. So 20 is divisible by 4. This is 4 times 5. So then you can break the square root apart into the square root of 4 and the square root of 5, which is 2 root 5. So that means that this part, this radical right here, is 2 root 5. So as long here, I'm going to go up to the top here. This is x is equal to 6 plus or minus 2 root 5, all divided by 2. Now, because the 6 is divisible by 2 and 2 root 5 is divisible by 2, you can just go ahead and divide them. So 2 goes into 6 3 times. You get 3 plus or minus root 5. And that is your answer, your two answers, 3 plus root 5 and 3 minus root 5. Next up. It's not in the form ax squared plus bx plus c equals 0. So I'm going to scoot everything to one side to get 6x squared minus 7x minus 5 is equal to 0. Then our a is equal to 6, our b is equal to negative 7, and our c is equal to negative 5. So if I say x is equal to negative 7, so negative b plus or minus the square root of b squared minus 4 times a times c. And this is all over 2a. Now let's start simplifying. So negative 7 is positive 7. Negative 7 squared is 49. Then I see inside this parenthesis here, there's a negative here and a negative here. So those will become a positive. So 4 times 6 times 5. I think that's 120. And this is all over 12. Now I'll simplify inside the square root. And this is 7 plus or minus 169. That number should sound familiar because I think it's a perfect square. In fact, it is. It's 13 squared. So back up to the top here. That's nice because it's a nice perfect square root, which means we're going to get 7 plus or minus 13 all over 12. So then x is equal to 7 plus 13 over 12, but also 7 minus 13 over 12. Here we get 20 over 12, and then here we get negative 6 over 12. So then if we fully reduce our fractions, let's see, those are divisible by 4, so that's 5/3 and negative 1/2. Now, you guys, because those are nice whole fractions, I suspect that back here, this is factorable. I bet we could have used smoke and mirrors. Yeah, I'm sure of it. All right, guys, we're just giving you a little taste of quadratic formulas class. Next class, we'll do a lot more with it, and we'll talk about that b squared minus 4ac a lot.